Well, the scenarios make it clear. There will most definitely be further warming. In any case, we'll have to adapt to life in a warmer world. What does this mean for us? What does the climate in a warmer world look like? Just warmer? Well, this is what Dr. Tatiana Ilyina, research assistant at the Max Planck Institute for Meteorology in Hamburg, is working on.
What will our climate look like in the future? Many model predictions provide us with an answer, which is different for everyone, depending on where they live, how wealthy they are, and how mobile they are. Nobody lives in the global average. A scenario with seemingly bearable consequences for us in Europe could be quite catastrophic for other people. So, how does warming affect different regions? Now, let us look at these two animations to understand air temperature trends in the future. We compare here a pessimistic scenario RCP 8.5 with an optimistic scenario RCP 2.6. The animations start in 1985. And now we see that the temperatures in both scenarios increase. We also see that they do not increase uniformly. For example, the warming over the continents and over the Arctic is stronger than the warming over the oceans. And this is because the oceans can absorb more heat. You can particularly see this in the Atlantic Ocean and in the Southern Ocean. And this is because there are vertical mixing processes in the oceans which transfer heat into the deep ocean. Now, air temperature and precipitation respond very quickly to climate change. However, other components of the climate system change more slowly. For example, the sea ice in the Arctic. Next, we'll look at another animation. It shows us how the spreading of sea ice during summer in the course of the 21st century changed in both scenarios. Now, the amount of ice increases and decreases in the course of the seasons, and this is not shown in this animation. The animation just shows the ice cover in summer. And here we see that the amount of ice significantly decreases in the course of the 21st century. In the RCP 8.5 scenario, the sea ice in the Arctic has almost completely disappeared by the end of the century. The sea level also responds very slowly to climate change. The sea level is, so to speak, the elephant of the climate system. It does not forget. The sea level rise is due to thermal expansion and melting ice. And this sluggish response is just difficult to alter. The sea level will rise beyond the year 2100, even if an ambitious climate policy were to stabilize the global temperature increase to under 2 degrees. However, there will be dramatic changes in the oceans even beneath the ice. Observations and model simulations indicate that the pH values have declined already by approximately 0.1. This means that the oceans are becoming less alkaline and more acidic. A 0.1 change in pH may not sound like much, but this means that the concentration of hydrogen ions has increased by 26%. This is very well illustrated in this graphic. As long as CO2 emissions increase, thereby increasing the concentration of CO2 in the atmosphere, the pH will drop further. The following animation illustrates the regional pH distribution for the scenario RCP 8.5. Our model projections shows that all ocean regions are affected by ocean acidification, but high latitudes and polar regions change in a particularly significant manner. The pH changes in the tropics are lower. Due to the increase in ocean acidification, it's not only the seawater pH that will decline, but also the concentration of carbonate ions. Now, carbonate ions is an essential component for calcifying organisms, such as some types of phytoplankton or zooplankton, which need calcium carbonate to build their skeletons and shells. And this can be nicely illustrated with a value called omega. Omega indicates whether seawater is undersaturated or supersaturated with respect to calcium carbonate. If omega has a value greater than 1, then the seawater is supersaturated with respect to calcium carbonate. If omega has a value less than 1, then the seawater is undersaturated with respect to calcium carbonate. And in this animation, which shows us the behavior of omega in the 21st century, we see that the ocean surface water is currently supersaturated with respect to calcium carbonate. The deep sea too, such as that in the Pacific, can be undersaturated even today. This is represented by the blue colors on the animation. Calcifying organisms can very well build their shells and skeletons in supersaturated water. Undersaturated water makes it difficult for them. Now, if we look into the future, we see that there will be regions, even on the ocean surface, where omega values are less than 1. Therefore, there will be conditions in seawater for calcifying organisms which are less hospitable than today. So far, we have talked about development in temporal averages. However, we also expect climatic extreme events to become more severe or more frequent, for example, extreme heat or extreme precipitation. So these were the major changes in the climate system in the 21st century, and there will be significant changes that we will have to take into consideration.